Hi, I'm Ed Zinda, and this is What the Funk. In this video, we're going to show you how incredibly easy it is to create upgradable Ethereum smart contracts using Zeppelin OS. Before we get started, make sure you subscribe to my channel, click that notification icon so you receive updates on more content like this. Let's get started. To create an upgradable smart contract, we're going to use a library called Zeppelin OS. And this is created by the Open Zeppelin team, the same team you might be familiar with who creates a bunch of open source smart contracts for things like ERC20 tokens, crowd sales, and different modifiers for those different contracts. To get started, we need to install Zeppelin OS. So the easiest way is to either use npm or yarn, install it globally, and install ZOS. I've already done that, so I'm going to skip that. Next, you want to create a new project directory. I've already done that. I've called it ZOS demo. You want to initialize the project using either npm init or yarn init. I'm just going to go through all the defaults. And then the next thing we want to do is ZOS init. And then we want to give this application a name. So I'm going to call it greeter because we're going to create a contract that basically does a simple hello world or prints out a string. So we've got that. And you can see it's created a bunch of different folders and files for us. It's actually just created an empty truffle application for us. So let's open this in code. And you can see it's already set up our truffle config to point to localhost. And we're going to use Ganache as our development chain. I've already got that running here. So to create our upgradable smart contract, we have to create a smart contract to begin with. So let's create one. We're going to call it greeter. We'll start it as we always do by specifying the Solidity version. And we've got this contract greeter. Now to make this upgradable, we need to import a library called upgradable from the Zeppelin OS library. Let's install that now. Okay, that's installed. Now we can import it. And we need to set this contract to upgradable. Now, the main difference between this and normal smart contracts is that we can no longer use a constructor. So if we need any sort of constructor method to initialize variables or whatever, we actually use what is called an initializer. We do this because the way Zeppelin OS manages these contracts is that it creates an instance of your contract, but then puts it behind a proxy contract, which uses delegate call to make calls to that implementation of your contract. So that when you update your contract, you're actually just pushing a new version of that contract onto the blockchain and then setting your proxy contract to point to that new version. So we're going to create an initializer. It's going to take a string. That's going to be a name. And we need to add this is initializer modifier. And it takes two arguments. The first is the name of the contract. The second is the migration ID. So the first initializer you create has to start with an ID of 0, and then you increment when you upgrade your contract. So if you have a new version of your contract, you're going to set the migration ID to 1, and then the next one 2, 3, 4, etc., etc. But only if you're actually initializing something when you're pushing your new version of the contract. So the only thing this initialize function is going to do is set a variable name to whatever is passed in as an argument. forgot this needs to be set to public. It would also help if I spelled migratable correctly. And then the final function we're going to add is a greet function. And it's just going to be a public view function, and that returns a string. And that's just going to return our name. Now we need to compile and push this contract to the blockchain. So first thing we do is run ZOS add greeter. So it's compiled our contract, and if we go back into code, we can check this zos.json. It's added our contract into the configuration. The next thing we need to do is push this to the blockchain. So we run ZOS push, and then we need to specify a network. And the only network we have specified is this local network, so we'll use that. So that has been compiled and deployed to the blockchain. So let's check out this zos.local.json file that's just been created. So ZOS will actually create different configuration files depending on the network you are working with. So if we push this to a live network and we had that configured, the settings would be changed in zos.json. But in this case, we're using a local network. It's going to change zos.local.json. So we've got the same contracts object like we did in the first file, the greeter contract, but this case we've added some extra metadata. So we have the address. So this is the actual Ethereum address where this contract is deployed. Some other information, bytecode, body bytecode. We don't need any of this. And then down here, we have this proxies object. Well, right now it has nothing because we haven't actually created an instance to interact with on the blockchain. So in order to be able to interact with this upgradable contract in the context of Zeppelin OS, we need to create it on the command line. So we'll do that now. So to create this, we run ZOS create greeter. And because we had this initialize function, we want to run init. And then we give init the name of the function, that is the initializer. We just called it initializer. And then it takes some arguments. The only argument it had was that name argument, so we're just going to pass a name. I'm just going to pass my name. And we also need to specify the network we're working with again. So we've called the greeter proxy, called the initialization function, and passed it the name ed. So let's go ahead and check out what changes have been made to zos.local.json. So you can see now in this proxies object, we have a greeter. And the greeter proxy has an address parameter, and that actually points to the address of the proxy contract that's been deployed. And then it also has this implementation parameter, and that points to the current implementation of the greeter contract. So you can see this ends with 459. If we look up here, this is the first implementation we deployed to the blockchain, 459. So that's our first version, and that's what the proxy is pointing to. So let's interact with that on the command line. If we run truffle console, make sure we specify the network as local. Let's grab an instance of the greeter. So we're going to need the address, so let's copy that. So rather than copy the address of the greeter contract, we're going to copy the address of the proxy. We've pasted that in there. We have our instance, and let's run that greet function. And you can see it prints out my name. Now what happens if we want to upgrade this contract? What if we want to have the greet function spit out a little bit more information, such as my name is Ed? We can do that by creating a new version of this contract, pushing it to the blockchain, and telling Zeppelin OS to use that new implementation. So let's do that now. In the contracts folder, we're going to create a new contract. We're going to call it Greeter version 2. So I specified my version. We've created our Greeter version 2 contract. Now the next step is to pull in the old contract and then inherit from it. This way we can utilize the state and structure of the original contract and only modify what we need. So let's import that. And then say that Greeter version 2 is a greeter. Forgot my semicolon. Now the next step is to modify the original greet function. We're going to use basically the same signature, but we're just going to tack on my name is. There's no real intuitive way to concatenate strings in Solidity, but I found a really cool hack using the ABI encoding library that's built into Ethereum. So basically, if we use this ABI.encodePact and pass a series of arguments, doesn't matter what type you use, you can pass an int, a string, an address. It will basically take the bytes value of each of those variables and then concatenate them together and then spit them out as hex. But in order to spit this out as a string, we just need to cast it as a string. So what I'm going to do is add this string, my name is, and then the next argument is going to be the name. And then we cast this as a string. And this will return the name with my name is appended to the front. So this is the new version of our contract. We need to push it up to the blockchain and tell our proxy contract to use this new implementation. First, we want to update the version of our application or contract. We use the command ZOS bump. And let's call this 0.2.0. Next, we want to add our version 2 to the blockchain. So we use ZOS add. And then we want to tell ZOS that we want to use Greeter version 2 in place of the original Greeter. Next, let's push it to the blockchain. And we can see that version 2 of the Greeter contract has been deployed to this new address ending in E56. Let's check out the config. You can see that Greeter, under the contracts object, has a new address ending in E56 as well. But we can see that our proxy Greeter is still pointing to the old implementation ending in 459. So we need to fix that. We do that using ZOS update. So the proxy has been updated. Let's check the config. And now you can see the proxy is pointing to the new implementation ending in E56. Let's check it out in the console. We'll grab our implementation. Notice that the address we use doesn't change because the proxy contract stays the same throughout the life cycle of your application. The only thing that changes is the underlying implementation of your different versions of your contracts. So we have our instance. Let's run the greet method. And you can see that our new version of the greet method is what is running. So it says my name is Ed rather than just Ed. And that's it. That's how easy it is to create upgradable smart contracts using Zeppelin OS. As always, if you enjoyed this video, go ahead and give a little tap to that like button. Leave your questions and your comments down below, and I will see you in the next video.